Okay, part 2, cube root functions. So basically the difference between this and the square root is the power of the function. We're using the third power for the root. So this is called the cube root. So when you put these numbers in here, they're not nearly as big as from the square. Now here's the difference. There's negative numbers now. Now if you just looked at half of it, it looks just like the other one. The difference now is that it includes a negative set of coordinates going this way. Okay? So this is the parent function. This is what it looks like. Of course, same as before, you can change it. So for example, here, if you add a number or if you subtract a number, what would that do to those points? Well, if it's at 0, 0 in the middle, that middle point will move down 1, 2, 3 right here. And the other points would also move down the same amount, but your shape would stay the same. You still have a curve going this way, and you still have a curve going that way, like that. Okay, so that's what happens when there's a number on the outside. Now, if the number's on the inside, like this one, for example, positive 3, positive 3 would actually move it 1, 2, 3 over here to negative 3. And it goes up again, and it goes down again, like that. So it keeps the same shape, but that middle point is just going to move, and that means every other point moves. So the graph has shifted or translated. So we're going to follow the same format. We're going to use H and K. H moves it horizontally, K moves it vertically. All right. So if we have a problem like this, if they want you to translate this function 4 units to the left and 3 units down, what does that look like? Well, let's just take this. Let's say we take the center point, we move it 4 units left, 1, 2, 3, 4, 3 units down, 1, 2, 3. There's our center point now. It would go up like this, and it would go down like that. And that would be where our function is now. And your center point right here would be at negative 4, negative 3. So what if you take those numbers and plug them in? Your function for this cube root would be h plus 4 minus 3. And again, because you're plugging in a negative number, that negative sign inside becomes a positive. And because you're plugging in a negative number here, that plus sign becomes negative. It changes the signs. Now let's talk about domain and range here for a second. Domain and range is basically when you are telling me what x values you can use. And guys, the good news is for both of these, domain and for range, it is all real numbers. Because you're going in the positive and the negative direction, even after it's moved, it's still going up and it's still going down. The domain and range is all real numbers. Now, normally the x and y intercept would be here in the center at 0, 0. But since you moved that point, your x and y intercepts are now in different places. So one of the things you can do to find that is if you go to Desmos, okay, but instead of going to the scientific, let's say we go to graphing. So Desmos graphing. You can plug in the function and find the intercepts this way. So let's just say we go to square root. Put a root, but I want to put a power. I want to do the cube root. I don't know if it's going to let me actually. It might not let me. Okay, so I'm going to show you a trick. Inside the parentheses is what's inside the square root, okay? X plus 4 minus 3. Okay, but that's just a line, you're right, because it's missing the square root. Now the problem is I couldn't just use square root, I need a cube root. So there's something you can do and that's use this. One third as a power is the cube root. So if you use this as your exponent in the calculator, you can model what it looks like. And here we go. Here it is. There you notice that's where our point is now at -4, -3. Now, here is your y-intercept, approximately -1.4. Sorry, y. I messed up. That's the y-intercept. The x-intercept, however, oh, just went away. I would have to keep scrolling till I find where it crosses it. And I think I found it. At 23, wow. That's my x-intercept. Let me scratch this off. That's twice already in these lessons I've had to scratch off an error. But yeah, this would be the most helpful to define the intercepts for you. Plug it in, move the graph around. That'll be the most helpful thing to do for x and y intercepts. All right? All right, now, the last thing I want to show you before we end cube roots is how to find the average rate of change. It's very similar to what you did in the lesson for square roots. You're going to plug in your interval. So you're going to plug in 4 into the function, and you're going to plug in 7 into the function. Okay, so in this case, it would be 8. And in this case, it'll be 14. Then you got to take the cube root. Cube root of this is 2. Now I need a calculator for this. I need the cube root. You see, this one lets you put the cube root, so that's nice. 14, 2.4. See, not that big a difference. Okay. We're going to use the slope formula. y2 minus y1, x2 minus x1. Remember, you can treat this like coordinates. Your x was 4, your y is 2. Your x was 7, your y is 2.4. So we plug in these numbers. 2.4 minus 2, 7 minus 4. I get 0.4 over 3. Again, take my calculator. Clear this. 0.4 divided by 3. 1.3 repeating. So the answer is 1.3 repeating. That is the average rate of change.